Now, factoring is kind of the backbone of algebra, and it's something that you need to be able to do almost as well as you know how to breathe. So when we are faced with a four-term expression, our strategy always is first to look for a greatest common factor. Greatest common factor must exist in all the numbers. And when I look through the coefficients of 21, 6, 49, and 14, there's no greatest common factor. So then our next strategy is to somehow group our numbers so that we can find a greatest common factor and perhaps make some sense of this. Remember, factoring is undoing multiplication. It's undoing distributive property, it's undoing foiling. So we somehow want to turn this into something else. So my first strategy is just to go ahead and group the first two and group the last two and look for a greatest common factor. So greatest common factor of the first two would be 3r squared, and that would leave me 7r plus 2. And my greatest common factor of my second pair is to pull out a 7, and that also leaves 7r plus 2. Now this is great because then these back factors actually now are greatest common factors, so I can pull them out. And when I pull that out, it leaves 3r squared plus 7. And when I say pull out, remember we're undoing distributive property, so we are dividing. There are no common factors between 7r and 2. And there's no common factors between 3r squared and 7. So that is my final answer. Now, just be cautioned, you may have to reorder your four-term expressions to get them into an order where when you take out a greatest common factor, you're left with a greatest common factor. If your first grouping doesn't work, try to switch some numbers around and regroup. This idea of grouping also works when we are looking at trinomials, three-term items. Now number 15 is interesting because number 1, we do have a greatest common factor. So we're going to pull out a 5, but more so, we're going to take out a negative 5 because we never factor a negative squared term. You always want to factor out a negative, -1, or a negative coefficient so that you get that positive squared term. So I'm going to take out a negative 5. That leaves k squared. 20 divided by negative 5 is going to be minus 4k. Negative 15 divided by negative 5 is going to be positive 3. Really take care of your negatives. Now also, be sure you don't lose this negative 5. This is an expression, so numbers can't disappear. They must always be accounted for. Now, some of you may remember the trial and error, but if you don't, we are going to think about how can we rewrite this as a four-term factoring so we can do the grouping like we just did. And the way we're going to do that is we are going to multiply this last term times this first term. Now, in math terms, this is always ax squared plus bx plus c. It's a quadratic. So we're going to multiply that c times the a. So 1 times 3, and we have 3. And then we're going to list all the factors of 3. Now we're going to think about how can I rewrite -4 in terms of 1 and 3. Now remember, with every pair of factors, you have 4 different combinations. If these were 1 positive and 1 negative, I could rearrange it to get plus or minus 2. If they're both positive or both negative, I get plus or minus 4. And that's what I'm looking for, is if these are both negative. So I'm going to write negative k, -1k, and -3k. Notice I still have negative 4k. I've not changed the value of my expression. I just changed the way it was written. So now I'm going to group these first two, and I'm going to group the last two. I'm going to do greatest common factors again. So greatest common factor here is k, and that leaves k minus 1, plus, if this third term is negative, always factor out a negative. So I'm going to take out a negative 3, and that's going to leave k. Positive 3 divided by negative 3 is minus 1. Then, just like I want, that k minus 1 becomes a greatest common factor. That minus 5 is still hanging out. K minus 1 is my greatest common factor, and it leaves k minus 3. No more common factors. That is your answer. If you would have forgotten to take out the 5 and only pulled out like a negative 1, when you got down, one of your factors would have had a greatest common factor, and you just have to remember to pull that out. So there are the first two homework examples. Tune into the second video for another example.